Okay, in this video, we are briefly going to discuss the triangle congruence axioms. Okay, and you could say axioms or postulates. We've come to know by now that axioms, postulates, they're synonymous as far as we're concerned. Okay, so first one is what we call ASA or angle side angle. Forgot the dash. Okay, and it's important to remember here that when we say angle side angle, we mean the side in between. Or you'll hear some other teachers or math books call it the included side. Okay, and all that means, so let's say I have two triangles, right? Call this A, B, C. And let's say I have another one, and we'll call it D, E, F, right? And we see that we have, this angle here and this angle here are congruent. And we see that this side here, and I'm not going to do it like that, this side here is congruent with this side. And we see that this angle is congruent with this angle. Okay, so we see that we have angle, side, angle. Okay, and what we're saying here is simply like we said, we've got an angle being connected by, that's another word that we can say, right? So this side length, BC, connects our two vertices that are congruent, just like this side here, FE, connects the two common angles that they've got. Okay, so that would be angle side angle. Let's look at some other ones. Okay, there's 5 that we're going to look at, so we still got 4 more to look at. Okay, so now let's say we had uh, angle side, right? So let's talk about what that means. Well, that means, just like I said, angle side. Okay, and this is where the side is not in between or not included. Okay, so let's look at what that's going to be. And I'm going to try to draw a triangle that's different from last time. So let's say we have A, B, C. And let's say now we've got D, E, and F. Okay, if this here is true, well, then we can say, we've got an angle and another angle and a side in common, right? And what we mean to say here is, well, we've got two angles that they share, right? That they have the same, and they have a side length, right? Now this time it's not the side that connects the angles. Okay, and yes, I know that's not how you spell connects, right? I'm just abbreviating. I'm a math teacher, not an English teacher. Anyway, so that would be angle side, right? So if you have that, that means the two triangles are identical. Okay, so if I pretty sure I've specified it with you in class over and over again, but congruent means equal, the same, identical, right? So if either of those two theorems is true, then that means those two triangles are identical. Okay, and then this is the easiest one to understand. Side, side, side. This should, sorry, this one's just kind of dumb, but three sides congruent. Well, duh, if I've got a triangle, and let's say that this is, I don't know, 7, 9, and 4, and then I have another triangle whose side lengths are also 7, 9, and 4, well, duh, of course they're congruent, right? So I'm not even going to go into really any detail here. If two triangles have three sides congruent, obviously that means the two triangles are identical and they too are congruent. Okay, so not going to dive too deep into that one. If for whatever reason you have any questions over that one, I mean, let me know, but I doubt it. Okay, and then we have side, angle, side. And you can already kind of guess this means so side, angle, this angle is in between now, in between or uh, included, right? And you'll see what I mean here in a second. So side, angle, side, right? Now let's say this is the triangle we've got. We've got A, we got B, and we got C. And then we have another triangle, D, E, and F. Okay, so if this is true, then the two triangles are going to be congruent. So let's see what I mean by this. So let's say this longest side here, we label that 1. We label this 2, and this angle 1. Well, let's say they have that precisely in common, right? So we're saying that this side are congruent. This side are congruent, and the angle in between the two congruent sides is also congruent, right? Well, then that means these two triangles are themselves congruent. Okay, and last one, and this one's kind of well, it's not really a special case. This one actually refers back to, if you know the other 4 axioms, you don't really need to know this one, but this one's just kind of a shortcut. So this one pertains to right triangles. I'm just going to abbreviate that. Right, so this stands for hypotenuse, leg. Right, and in case you forgot, the hypotenuse is the side opposite of the 90-degree vertex. Right, legs are the side lengths that, so I'm going to say one of 2 sides that form the 90-degree vertex. Okay, so if I've got a right triangle, like so, and I label it A, B, C, and I know it's a right triangle because I have a 90-degree vertex, that would make AB here the hypotenuse because it's opposite, across from opposite of the 90. Okay, and that's something we reviewed heavily before, but just in case, never know. And we'll call this D, E, F. Okay, and DEF's hypotenuse is also opposite of the 90. It's that guy right there, again, because it's across from or opposite of the 90. Right, that means the legs are DF and FE because they form the 90, just like ABC's legs would be AC and CB because they form the 90. Okay, so if this is true, right, if they have the hypotenuse and a leg in common. So this hypotenuse here, I labeled it with 1 dash, right? So let's say DE also had the 1 dash, and AC is a leg. This leg also had 2 dashes. Well, that means they have a hypotenuse and a leg in common. right? That means that the two triangles have to be, we call it congruent.